Okay, in the next problem we have a particle moving along the x-axis in such a way that its position at time t for t greater than or equal to 0 is given by x is 1/3 t cubed minus 3t squared plus 8t. And the first thing we want to do is show that at time t equals 0 the particle is moving to the right. So the particle is moving to the right whenever the velocity is greater than or equal to 0. So we need to show that the velocity at t equals 0 is greater than 0. And I made a change above. It should be it's moving right whenever the velocity is greater than 0, not greater than or equal to 0. At equal to 0 it would be stopped. Alright, so we need to show that v of 0 is greater than 0, so we need to find the derivative. And the velocity function is going to be 3 over 3t squared, which is just t squared, minus 6t plus 8. And v of 0 is going to equal 8. So we know that the particle is moving right at t equals 0. Alright, so that's part A. For part B, we want to find all values of t for which the particle is moving to the left. And I'm going to practice using the sign chart. And so first I factor the expression t squared minus 6t plus 8 is equal to t minus 4 times t minus 2. And that will be 0 whenever t is equal to 4 or t is equal to 2. So on my sign chart, which I'm going to be looking at velocity, I place zeros at 2 and 4. I select some test values. I know that I can use 0, but I could choose a different value also. Now I've already shown that at time t equals 0 the particle is moving to the right. So it should be if I plugged in 1 into the derivative, I would get 1 minus 6, which is negative 5, plus 8, which is positive 3. So it's still moving to the right there. At t equals 3, I have 3 squared, which is 9, plus 8 is 17, minus 6 times 3. So it's 17 minus 18, which is negative 1. And finally, plugging in 5, I'm going to get, and I can use the factored form also, 5 minus 4 is 1, 5 minus 2 is 3, so 1 times 3 would be positive 3. And so the set of all values for which the set of all values of t for which the particle is moving to the left would be t is greater than 2, less than 4. And for those values, the particle is moving to the left. So the next question says, what is the position of the particle at time t equals 3? Well, for this we have to plug into the original equation, which is the position equation. And we get 27 divided by 3, which is 9, minus 27, which is negative 18, and that should be plus 8 times 3. So negative 18 plus 24 is equal to 6, and so the particle is at position 6 when time is equal to 3. In part D it says at time t equals 3, what is the total distance traveled that the particle has traveled? Well, if we go back to our sign chart that we did for part B, we see that the particle is moving to the right from time t equals 0 to t equals 1. Sorry, to t equals 2. From t equals 0 to time t equals 2, the particle is moving right. And then at t equals 2, the particle begins to move to the left. So we're going to have to find the distance traveled when it was moving to the right, and we're going to have to add to that the distance traveled when we move to the left. And the easiest way that I know to do that is to make a little table. We're going to need the position at 0, at 2, and at 3. And x of 0 is 0, and we know from part C that x of 3 is 6, so we just need to calculate x of 2. And so to do this, we have 1/3, 8. We get 8/3 minus 12 plus 16. So we're going to get 8/3 plus 4, which is 8/3 plus 12/3, which is 20/3. So we fill that into our table. That's equivalent to 6 2/3. So that means from time t equals 0 to t equals 2, the particle moves 6 2/3. And then from t equals 2 to t equals 3, it moved 2/3 units backwards, but we still count that. And so that would be 7 1/3 or 22/3.